Hello friends, today we are going to derive area of a triangle in Cartesian coordinates in analytical geometry, rather we can say coordinate geometry. So today in previous lessons we have done how to derive the distance formula, section formula, midpoint formula. Similarly, the very important section of coordinate geometry is finding the area of a triangle. So there is a formula for finding the area of a triangle. So today on this class we will derive the formula for the area of a triangle. Okay, area of a triangle, I will write you the formula here which we are going to derive today. So area of a triangle is equal to, in coordinate geometry, half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. This is the formula for the area of a triangle in coordinate geometry when the vertices of three vertices of the triangle are given. So we'll derive it. So before deriving it, we'll draw a diagram on the right hand side of the board. Okay, we'll draw the x-axis, name it, and y-axis, y-o, y dash, x-o, x dash. Now we'll draw a triangle here. This is our triangle and we can name it as A, B, C. And okay, let's suppose the coordinates of A is x1, y1. Similarly, the coordinates of B is x2, y2, and the coordinates of C x3, y3. The coordinates of C x3, y3. So okay, we'll start proving now. Given ABC is a triangle in which A, what is the coordinates of A? x1, y1, B, x2, y2, and C, x3, y3 are the vertices. Okay. Now ABC is a triangle in which A, the given coordinates, B, the given coordinates, and C, the given coordinates are the vertices. Okay. Now constructions. You need some constructions to prove this, to derive this formula. Okay. From A, draw a perpendicular on x-axis. Perpendicular on x-axis and name it D. Similarly, from B also draw a perpendicular on x-axis. Name it as E. And from C also draw a perpendicular on x-axis. You can name it as F. Now you have to write what you have done in the constructions. From A, B and C. What you have done? Perpendiculars AD, BE and CF are drawn respectively. Now see the diagram. What you have found here now. Now see here. Since BE is perpendicular and similarly AD is perpendicular on x-axis, CF is perpendicular on x-axis. So now, if this BE, AD, CF are perpendicular on the same axis, then what you can say, this they are all perpendicular. So BE is parallel to AD, AD is parallel to CF. These all three lines are parallel. So if you see it individually, for example, what is the ABED is a trapezium. We can call it trapezium. Why it is called trapezium? Any pair of a quadrilateral is a parallel, then the figure is said to be trapezium. Now see here, in ABED, B and AD are perpendicular. If they are perpendicular on the same axis, and they are also parallel. So this pair of sides of this quadrilateral are parallel. So what is this figure? The name of this figure, trapezium. ABED is a trapezium. Similarly, on the next side, on the right side, ACFD. In ACFD, CF and AD, these both are perpendicular on x-axis. So what we can say, the CF is parallel to AD. Again in this quadrilateral, ACFD. In this quadrilateral, one pair of sides are, we can say they are parallel. That means ACFD are, what are they are? They are trapezium. So how many trapeziums are here? One trapezium, two trapezium. Again you can see another trapezium here. So see this quadrilateral BEFC. See this quadrilateral BEFC. Now here also BE is perpendicular on x-axis, similarly CF. So both these are perpendicular on x-axis, that means they are parallel to each other. So one pair of sides are parallel, meaning this quadrilateral BEFC is also a trapezium. Now keep in point, there are three trapeziums. One trapezium ABED, second trapezium ACFD, and third trapezium is BEFC. And you know the properties of trapezium. If one pair of sides is parallel, then you can, any quadrilateral is a trapezium. So you need to find the area of this portion, triangle ABC. So altogether there are three trapeziums. So how do you find this area? Now just see the diagram. To find this area of ABC, what you have to do? You have to remove. To find the area of this ABC, you have to remove this portion. If you remove this portion, BEFC trapezium, then you will get the area of triangle ABC. So okay, let's move on. How do you find it? Now area. This is very important part. Area of triangle ABC is equal to, how do you get the area of triangle ABC now? Now, area of this trapezium plus area of this trapezium minus this area of trapezium. You will get the area of a triangle. Now see here. How do you find the area of triangle ABC? Area of this trapezium plus area of this trapezium. When you find the area of these two trapezium, you will find the area of this whole figure. So from this whole figure, if you eliminate this trapezium, BEFC, you will get the area of this triangle, and we are going to find this now. How do you find area of triangle ABC is equal to, first of all, area of trapezium. Area of trapezium, what is this? ABED. ABED plus again area of another trapezium. Area of trapezium. Now what is this area of trapezium here? ACFD. ACFD minus again this trapezium plus this trapezium gives the area of a full figure. So if you deduct this figure from this whole figure, that means this trapezium BEFC minus area of trapezium, what is trapezium? BEFC. So now you understood this, right? Area of this two trapezium minus area of this trapezium gives the area of a triangle. So here you need to know the formula of area of a trapezium. You have done it in 7th standard, 8th standard. So what is the area of a trapezium? Area, I will show you, area of a trapezium. What is the area of a trapezium? The formula is equal to half sum of the parallel side into height. Sum of the parallel side into height. So you have to recall this formula. Area of trapezium is equal to half sum of the parallel side into height. Okay, now let's move on. Now area of triangle ABC, will keep it as it is equal to, now area of trapezium ABED. Now see here, area of trapezium ABED. So what is the formula? Half sum of the parallel side into height. So half sum of the parallel side into height. So what do you name it now? Half sum of the parallel side. What is the sum of the parallel side? Sum of the parallel side is, okay, we didn't name it anything, so we should name it Z. This point is Z. Okay. Now, half sum of the parallel side. In this trapezium, what are the parallel sides in this trapezium? A, B, E, D. What is the parallel side? BE plus, what is the sum of the parallel side? BE plus and AD. Now into height, right? What is height here? Now what is height here? In trapezium ABED, can anyone tell me what is the height here? What is the height here? The shortest distance between the parallel lines is the height of the trapezium. So what is the shortest distance in this trapezium? What is the shortest distance? ED is the shortest distance. Since ED is the shortest distance between these two parallels, so ED will be the height of this trapezium. So we will write ED. So this is the formula of area of trapezium ABED. Plus, similarly again, what is the area of trapezium ACFD? Same formula, half sum of the parallel side into height. Half and sum of the parallel side here, ACFD. What are the parallel sides here? CF plus AD. Into, and what is the height? This into. What is the height here? Again, the shortest distance between the two parallel lines is the height of the trapezium. So what is here? FD or DF? What is DF or FD? Anything. It make the same sense. FD. Now minus, now area of trapezium BEFC. Minus area of trapezium BEFC. So sum of the parallel sides here in BEFC. In BEFC, what is the sum of the parallel side in BEFC? What is it? BEFC, BE and CF are the sum of the parallel side. BE plus CF into, now what is the height here? What is the height here? The shortest distance, what is the shortest distance? Sorry, in BEFC, what is the shortest distance between the two parallels? What is the shortest distance between these two parallels in this trapezium? BEFC. What is the shortest distance between two parallels? EF. You can write EF. EF. Now you got this. So you need to simplify. Okay, now you have to put the formula. Sorry, you have put all the formulas of the trapeziums. Now you have to put the values. Now, half B plus AD. First of all, you need to put the value of B, AD, ED, CF, AD, FD, VE, CF, EF. Now, half, you can, your half is common here. is equal to, you can take out half common, and within bracket BE plus AD. So what is BE plus AD? First of all, this remains here. BE plus AD, when you take out half common, within bracket ED plus, now half is already there, so you have to write CF plus AD FD, and half is already there, so you have to write BE plus CF here EF. So now half is already there, now you just need to put the values. So BE, now how do you find the value of BE? Since this is running towards the, BE is on the running towards the y-axis, so at the point B, the value of x-axis is x2 and the value of y is y2. So the distance BE is moving upwards. So the coordinates of B is x2, y2. So the value of BE should be how much distance it has covered on y-axis, y2. So the BE is y2, half BE is y2 plus, now AD. Similarly, AD is running towards the y-axis, so the value of AD will be y1, the y coordinates, y1. Now ED, what is ED? How do you get the value of ED? Now here, this is, ED is running on the x-axis, so from origin to D, the value of x-axis is x1, and now from O to E, the value of axis is x2. So to get the value of ED, what you have to do? You have to subtract this portion OD minus OE to get the value of ED. So what is OD on the x-axis? OD is x1. So we are getting the value of x1 minus, to get the value of ED. So to get the value of ED, OD minus OE will give you ED. So what is the value of OD? x1 minus OE. So what is OE here? x2. So we have substitute the value of this. Now similarly, plus, now put the value of CF. So what is the value of CF? It's on the y-axis. It's running on the y-axis. So what, you need to check the value of y coordinates. So what is the value of y coordinates of CF? y3 plus, now AD. What is the value of AD? As we have already seen before, the value of AD is also on the y-axis, so y coordinates y1. Again FD. How do you find the value of FD? So to get the value of FD, what you have to do? To get the value of FD, you can do like this, from EF minus DE. So when you subtract this EF minus ED, you will get the value of DF. So how do you find the value of DF or FD? How do you go to find the value of FD? You can find the value of FD now like this. Or you can subtract, to get this value, you can subtract OF minus OD. You can do that, right? To get the value of FD, you have to subtract from this to this portion. So from here, what is the value of x-axis? Since this is OF is running on the x-axis, what is the value of OF? OF is x3, because in the x-axis. So minus OD. What is OD? x1. So OF minus OD gives FD. The value of OF, x3. The value of OD, x1. So what you have to do? x3 minus x1. This is the value of FD. And minus BE. Now how do you get the value of BE? BE, as I told you, the value of BE is on y-axis. See the y coordinates, y2. y2 plus CF. Now CF is on y-axis, so the coordinates is y3. Now in the bracket EF. How do you find EF? EF, again the same thing. How do you find EF? to get the value of EF, OF minus OE. From this long portion, if you subtract OE, you will get the value of EF. So OF minus OE, right? OF means on x-axis, x coordinate is x3, and OE is on x-axis, x2. So what you have to write here? OF minus OE. OF means x3 minus OE. And what is OE? x2. Okay. Now with second bracket, close it. Now just need to multiply it. Is equal to half. Multiply it very carefully within bracket. Now 1 by 1 multiply it. y2 x1 za y2 x1. Multiply it very carefully so that you don't make any mistakes. y2 minus x1, y2 x1 minus y2 into x2, y2 x2 plus y1 into x1, y1 x1, and minus plus minus minus y1 x2. Similarly, plus again y3 into x3, y3 x3, and y3 into minus x1 minus y3 x1, and plus 1 y1 into x3 plus y1 x3, y1 x3 again plus into minus minus y1 into x1, y1 x1. Now minus will change everything. Minus into plus y2 minus y2 minus y into x3 minus y2 x3 minus y2 into minus x2 plus y2 x2. Again now plus minus into plus minus y3 into x3 minus y3 x3 minus into plus minus into minus plus y3 into x2 y3 x2. Now cancel the similar terms with the opposite sides. Now what you can cancel? What can be cancelled? Minus y2 x2 and plus y2 x2 will be cancelled. This and this will be cancelled. Similarly, plus y3 x3 minus y3 x3 will be cancelled. Now what more? Plus y1 x1 and minus y1 x1 will be cancelled. Plus y1 x1 minus y1 x1 will be cancelled. So what is remain now? When you simplify, what is remain now? Is equal to half within bracket. What is remain now within bracket? y2 x1 and what is remain? Minus y1 x2 minus y1 x2. Then what is remain? Minus y3 x1 minus y3 x1 plus y1 x3 then minus y2 y3 minus y2 x3, and lastly the plus y3 x2. So now is equal to half. Now try to take it out common. x1 check it. x1 here, and where is x1? Here, right? So in these two, what is common? x1 common. x1 within bracket y2 minus y3, and similarly, and here what is common? Plus x2 common. When you take out plus x2 common, inside the bracket how much? Now check here. x2, how many is the x3? y3 x2, y3 is minus, and x2 how much is how much? Minus 1 x2 minus y1 plus, now x3 common. here and here. What is common? X is common within bracket. X3, how much is y1, x3? y1 minus y2. So this way you have derived the area of a triangle. As I told you, what is the formula for the area of a triangle? This one. Area of triangle is equal to half x1 y2 minus y3 x2 y3 minus y1 plus x3 y1 minus y2. We need to derive this, so we have derived here half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So this is the formula we have derived. So therefore area of a triangle in coordinate geometry is how much? This one, half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So this is the area of a formula in coordinate geometry. Today we have derived. So we will go on to next sessions in the next class. Thank you very much.